Okay, welcome back to from the break. We're going to start on trigonometric ratios. The previous session we looked at the Pythagoras theorem, how to relate different sides of a right angle triangle. In trigonometric ratios, we are now going to consider the same thing right angle triangle, but how to relate different sides with the angles. We still have a right angle triangle, and we are going to call it A, B, and C. Remember, this is our hypotenuse. Then let us choose a reference angle. We don't need this one. This one is already known. We can only reference this or that, angle A or angle C. Now, if we reference, whenever you are using trigonometric ratio, you must first of all identify the reference angle. The reference angle in our case is angle A. Now, if that is angle A, then the name of the natural side will change. The name of the natural sides will change. Remember, in the trigonometry, in the Pythagoras theorem, we call them just sort of sides. But in trigonometric ratios, we change their names now to a different thing, depending on the reference angle. Now, if the reference angle is angle A, then this sort of side is going to be called opposite side. Then the remaining side is called adjacent. Adjacent side. Of course, it's adjacent to the theta. So that the triangle is fully named in terms of the hypotenuse, adjacent, and opposite angles. Okay. Now, from that is where we derive our trigonometric ratios. The first ratio based on this triangle. Remember, this triangle is having its own reference angle. Number one, we have sine rule, sine theta. Remember, we are referring to this theta here. Sine theta is equals to opposite over hypotenuse. So that if you find the ratio of the two sides, will give you the sine of this angle. Number two, cosine theta is equals to what? Adjacent all over hypotenuse. And then number three, we have tan theta is equals to opposite over adjacent. Okay, these are basically from the reference triangle which we have just drawn there. Now, these three ratios are very, very important. I want to show you how to memorize them. Because you might not really they might really confuse you which one comes on what. I have the first letters of each. I'll take these first letters of each, this one, and that, then this one, and that, this one, and that. So the first one to form for me a memorizable word, I'll have S O H. Remember, sine is equals to opposite of hypotenuse, and then C A H, that means C, cosine adjacent of hypotenuse, and then T O A, SOHCAHTOA. This one can easily help you to. That one comes in once you have already made the reference of your triangle. Let us give an example without necessarily looking at even the formula up there. So let us have this example here, and I want to change it. I want to change it to look a bit of a different shape. I want to change it like that, maybe. Okay, let it look that way, so that I have my right angle there. Then it is ABC. I have A, B, C, and then I wanted to call this one to be the what? To be the reference angle, theta. Then this side is going to be side B, side A, and side C. So can you write all the ratios? So sine theta, remember it is opposite over hypotenuse. Hypotenuse here is A, opposite to the right angle triangle. Opposite of this is B, so it will be is equals to B over A, where B is the B is the opposite of the angle theta and A is the hypotenuse. Next one is cosine theta. Cosine theta is adjacent of hypotenuse. Adjacent is set aside C over A, and then tan theta is equal to opposite, which is B all over C. Okay, good. Example. We are going to have this triangle PQR, and the angle of reference is this one here. This is the right angle triangle. This is 12. This is 3. I mean 5. How do we get this is Q. Find Q and theta. How do we find Q? Q can be found very easily because we know this right angle triangle and we know this other side and the other side. It means we can use Pythagoras theorem easily to find Q, very easily, without going through the trigonometric ratios. So using Pythagoras theorem to find Q, use Pythagoras theorem. Q is equals to 5 squared plus 12 squared square root is giving you 13. So Q is 13. Good. So we can find the value of theta. Cosine of theta. Find the sine of theta. Sine of theta is equals to opposite, which is 5 all over 13. That is giving you 0.3846. Cosine theta is equals to 12 over 13, which is giving you what? 0.9231. And then tan theta is equals to opposite, which is 5 all over adjacent 12, giving you what? 0.4167. Okay, Good. So we need to learn how to get this theta. You know, this angle here, this value here, is just sine of theta. But what about theta? What is theta? Same as this one here, it's just a cosine of theta. What about theta? We need to find that. Then same as this one. Here, this value 0.4167, which is also tangent of theta. But what about the value of theta? So in our next lecture, I'm going to show you, or in our next after short break, I'm going to show you how to make use of a calculator, scientific calculator, in identifying the value of theta given sine of theta, and also to evaluate different trigonometric values in our next session after a short break. Thank you. Let's meet in the after the short break. Thank you.